Hello everyone, I am Gleiss Cruzado from PHYS. For today's video, we will answer two questions that will help us to recognize the time dilation and length contraction under the special relativity. For the first question, imagine that you are in a spaceship traveling directly away from the moon. With a speed of 0.9 light speed, a light signal is sent in your direction from the surface of the moon. As the signal passes your ship, do you measure its speed to be greater than, less than, or equal to 0.1 light speed? As we know, just as time is slower for moving objects, the length of an object is measured to be shorter when moving than is at rest. And for the answer for number 1, when the signal passes our spaceship, we will measure the speed of signal greater than 0.1 light speed. Yes, because the speed you measure will be greater than 0.1 light speed since all observers in initial frame measures the same speed of light. Always remember that the speed of light is always constant. Did you get it, guys? Alright, let's move on to the next scenario. A street performer tosses a ball straight up into the air and then catches in his mouth. For each of the following observers, state whether the time they measured between these two events is the proper time or dilated time. For letter A, the street performer. B, a stationary observer on the other side of the street. Letter C, a person sitting at home watching the performance on TV. And in D, a person observing the performance from a moving car. The definition of proper time is the time difference between the two events which occur at the same location by a given observer or a particular observer. Here in the given problem, the two events are a street performer tosses a ball straight up into the air and then catches it in his mouth. Now, we have to decide for the following observers whether the time they measured between these two events is the proper time or dilated time. Here, the street performer is in the rest frame of reference. With respect to this street performer, these two events occur at the same location. So, he measured the time between these two events in proper time. Then, the stationary observer on the other side of the street is also in the rest frame, just like the street performer. With respect to her, these two events occur at the same location also. So, she measures the time between these two events in a proper time. Next, the person sitting at home watching the performance on the TV is in the rest frame also. With respect to him, these two events occur at the same location. So, he measures the time between these two events in a proper time. Lastly, a person moving in a car observed these two events are situated at different locations. So, with respect to him, he measures the time between these two events is dilated time. Always remember that when we say proper time, it is when the time of the moving clock is correct as far as an observer moving in the same frame of reference as the clock. However, when we say dilated time, from the word dilated, the time recorded by stationary observer in the same time interval is longer or dilated.